Biomech probs, finding segment lengths, a series of Biomech talk. So the problem we're going to solve today is finding the length of a thigh segment using endpoints that we found from digitizing using a pixel meter ratio of 100 pixels per meter. This video is a good example of something we could digitize in order to get segment endpoints to calculate segment lengths. To solve this, we're going to use the problem-solving process that I set up in a previous video. We'll start by filling in our header with our name, the name of the class, the number of the assignment, and the problem number, as well as the date and the number of pages that we have in our assignment so far. Then we're ready to fill out our problem statement. For this question, our problem statement would be find this thigh length in meters. For assumptions, we're not making any assumptions, and then we can fill in our knowns, which are the x and y pixel coordinates of the hip and the knee, and also the pixel to meter ratio. Then we're going to draw a really good figure of our problem. So I'm going to draw a thigh segment, a shank segment, and a foot segment so we can get an overall visual of where these points are going to be on the diagram. And we can double check that our x and y coordinates of the knee and hip make sense. So we can see that the y coordinate of the hip is higher than the knee, which makes sense based on our picture. And then we can also add information about what we're solving for, which in this case is the length of the thigh. Now that we got that all set up, we're ready to solve. So we're going to be using Pythagorean's theorem, which is a squared plus b squared equals c squared. C squared in this case is the length of our thigh, which is what we're trying to solve for. And then we're going to use the x and y coordinates from the hip and the knee in order to figure out our a and b distances. Then we're going to rewrite the Pythagorean theorem using the information that we have available to us. So for this equation, we're going to have hip y minus knee y squared plus knee x minus hip x squared, and hip y minus knee y is going to be equal to a, and knee x minus hip x is going to be equal to b. And that whole term is going to be equal to the length of the thigh squared. Then we can go ahead and substitute in our pixel values that we have, and then we can rearrange the equation so we just have the length of the thigh on the left side, and then we're left with the square root of all that information on the right side. Then we can plug that information into a calculator or somewhere online to solve for the length of the thigh in pixels. And we're going to end up with a value of 46.14 pixels. However, we need the length of our thigh in meters in order to answer the question properly. So we're going to take our pixel to meter ratio and then multiply that by the 46.14 pixels. We need to make sure that we have the right units set up. So we're going to have pixels on the bottom and meters on the top. And then once we divide the 46.14 pixels by 100, you can see that we're left with 0.46 meters, which then we also want to check to make sure our answer makes sense. So we calculated 0.46 meters for the length of the femur. If we convert that to inches, it's approximately 18 inches, which is the average length of an adult femur. So the work that we did makes sense. A series of Biomech talk, Biomech probs, finding segment lengths.